Hi again and welcome to Lesson 4 of Android App Development Training Course. Today, you'll understand the basics of Kotlin programming language and its place in Android development. You will know the data types and the different ways on how to declare and initialize a variable, the different conditional statements like if and when. You'll be working with loops, arrays, lists, and enumerations, and you will learn how to refactor your code by creating different functions, as well as how to incorporate basic error handling in your code. Most importantly, you'll learn all the basic topics while building a simple calculator app step by step. So, if you're ready, then let's begin. For this demonstration, we will be working with the challenge that I gave you in Lesson 3, the calculator app layout. But don't worry, you'll still be able to accomplish everything that I'm going to show you here, regardless of how you created your screen layout from last time. So if you want to follow along as I code, my only suggestion is to make sure that you use the same ID for each of these view components because we are going to reference these IDs as we write our code in Kotlin. This text view has an ID of TV display. Then, this is button add, button sub, button mul, button div, and button equals. Then, for the number, this is button 0, button 1, button 2, button 3, button 4, button 5, button 6 up to button 9. Then we have the button del and the button clear, and also the button sign and the button dot. I'll open my main activity.kt file, and to start working with this calculator app, we need to know how to declare variables with data types in Kotlin. There are two ways to accomplish this in Kotlin. We either use a keyword val or var. So what's the difference? Let's use it right away. Then after seeing the result, I'll explain to you the difference. So I'll say val num1 colon int equals. So in here, it simply says, I need a variable of type integer with its value set to 5. But unlike with any C-based programming languages, semicolon at the end of each line is not required. Simply go to the next line. Then next, I'm going to use var instead of val and say var num2 colon int. In here, if I don't want to assign the value right away, I can do it later, like place it on the next line and say num2 equals 10. And then next, I'll declare another variable here, val sum of type int. Then let's have a simple arithmetic operation to add num1 and num2. So how do we display the result then? If we work with a console application, then we can simply call the print function and display the content of this sum variable in a console window. But since we are working in an Android environment, we are going to use one of the view components here that we have. Obviously, we'll go with the text view. Take note that the ID of this text view is TV display. If you have worked with a classic desktop application before, it is tempting here to simply type the ID of this text view. And as you noticed, when I do, TV display turned red and cannot be recognized here as a valid identifier. In Android development, the IDs you define in your XML layout file don't magically appear and become accessible here in the Kotlin activity file. We have to manually create a variable to reference any components in the XML layout that we want to access here. This is the same even if you're using Java instead of Kotlin. So I'll use this TV display as a local variable here instead by using the keyword val and specifies a data type of text view. And to assign a reference to the text view component TV display from our layout file, I'll use the classic way of doing it, calling the findViewById function. The findViewById function is a function that finds the view from the layout resource file that is attached with the current activity. If you recall how this R class works from the previous lecture, R is a special auto-generated class in Android that holds a reference to all the IDs of all the views. And as you can see, the TV display ID now appears in the IntelliSense. I'll hit tab to complete this code. After this, I can simply use this local variable TV display to access its attributes and methods in my code. I'll access the text attribute, and now I can assign the value stored in my sum variable. Since Kotlin is a statically typed programming language, therefore it is type safe. The IDE knows it and the compiler knows it. It will not allow you to assign value to a variable that is not of the same type. You see this red squiggly line appearing at the sum variable which denotes an error. But unlike with Java, even the primitive types here in Kotlin uses a class. And for each type, you can use any of these methods or functions to convert one type to another. I'll use this toString function to convert num1 to string before assigning it to the text attribute. Now, let's check the output in the emulator. And as you can see, the value sum, which is 15, is now displayed in the tvDisplay's text attribute. Let's go back to our code and investigate on it. Notice that the int declaration here has some sort of a lighter gray color as compared to the other int type in the other declarations that we have. Even though Kotlin is a strongly typed language, you are not required to specify the type the moment you assign a value to your variable. Kotlin will automatically assign a type based on the value that you assign. So in here, let me just duplicate this code and comment the previous one. Now, even if I remove the type declaration to it, it should work fine. The num1 and this sum variable will be given a type based on the value that it holds. If it is numeric without decimal places, the default is integer. If it has decimal places, then it will be set as double data type. If you enclose it in a double quotes, then it will be of type string, and so on. For the list and discussion of all the data types that is supported by Kotlin and the rest of its programming construct, you may visit the Kotlin's official online documentation at kotlinlang.org/docs/reference. But in this video, I'm going to highlight only some of the important concepts and basic programming constructs to get you started right away in building your Android apps. Take note that Kotlin language is not only intended for Android development. It is a general-purpose, free and open-source programming language that is initially designed for the JVM or Java Virtual Machine in Android, but the recent version are focused on Kotlin targeting JavaScript as well as the native code, which can run even without a virtual machine. In Android Studio Editor, when you see a gray squiggly line, it doesn't mean an error, but instead a recommendation. When I hover my mouse, it says here that this declaration can be joined with assignment, which is here, separated on the next line. Okay, let's follow the recommendation to make our code more concise. Going back to our initial question, what is the difference between the use of these val and var keywords, since it looks like they work similarly? Well, your decision should be based on this. You use var when you want to treat your variable like an ordinary variable, wherein you can assign value to it multiple times. This is also known as mutable variable in Kotlin. I'll assign a new value to num2, which is 20. And if we check our output on the emulator, you see that the value of sum is 25. Now notice what happens if we try to modify num1, where you use the val keyword instead of var. I'll assign a new value of 8. In here, you'll see an error saying val cannot be reassigned. And if you want to reassign its value, use var instead. In Kotlin, when you use val to assign a value, it cannot be changed. It is known as immutable variable. So if we're going to continue building this calculator app, we need to declare variables for all the buttons that we have, so that we can respond accordingly when we click these buttons. Event listening in Android development is mostly focused around the view objects. Any view like a button or a text view has many event listeners that can be attached using the setOnEvent pattern, which involves passing a class that implements a particular event interface. This includes listeners like setOnClickListener, a callback when the view is clicked, setOnDragListener, setOnFocusChangeListener, setOnGenericMotionListener, and so on. Let's take this setOnClickListener for example, and as simple as it is, you can start writing anything inside this code block in response to this button click, like changing the text attribute of this tvDisplay and setting it to 9. I'll apply the changes and restart the activity. And when I click this button 9, the text view changes its display to 9, and it keeps on displaying 9 every time I click it. If you've been developing Android apps in Java for some time, then definitely using the findViewById method is a part of your day-to-day life to retrieve views defined in your XML layout. Typically, you need to declare a variable, then call the findViewById function by passing the resource ID of the view you want to retrieve. although simple but sometimes tedious, since you'll be doing this for every view that you want to reference in your code. There are also other issues that I will not be discussing here in this topic. So as an enhancement to this, there are some libraries that existed to make this approach simpler, like the butter knife, which partially improves the boilerplate code issue, but unfortunately it is now deprecated. Then in 2017, with the release of Android Kotlin extension Gradle plugin, came the Kotlin Synthetics, that for every layout file, it creates an auto-generated class containing your view. Kotlin Synthetics was so convenient, but unfortunately, as of December 2020, it was declared to be deprecated as well. You'll see it in the Android developers documentation. Migration to Jetpack view binding is highly recommended. But for illustration purposes, I'll show you how simple and convenient this deprecated Android Synthetics first. All you have to do is to apply this plugin in your build.gradle file, click Sync Now, and in the Build menu, click Build Bundle. As simple as that, you are all set to directly refer to the view reference variables. Notice here now, as I type button, all the buttons defined in my XML layout is accessible right away without having to explicitly use the findViewById function, except for this button 9 which we have used the findViewById earlier. Well, internally, it still calls the findViewById function but only once and then caches it. When I use this button 8 for example, it automatically adds an import statement at the top for the Kotlin X Android Synthetic. So for this calculator app, I'm going to use this Kotlin Synthetics for now just to make it simple, and we'll start to use the view binding in the next video. Going back to this button 8, I can apply the same set on click listener and place a code TV display the text equals 8. I'll do this for button 7 as well. And now let's run the app and see the result. I click 9, 8, 7, 8, 9, and everything works as intended. Eventually, you'll have several lines of code inside this code block, and you might want to place it in a separate code block. To do that, I'll highlight this code and right-click, choose Refactor, and then click Function. So in this Extract Function dialog box that appears, the default visibility is set to private, and we are asked to give a function name for this block of code. I'll type button 9 clicked and press enter. Notice that this code is now replaced with a function call button 9 click, and inside this parenthesis, the argument TV display is passed. Since this TV display is a local variable declared here inside this onCreate function, its scope is not directly accessible to another function outside this code block, like this button 9 click. So through parameter passing, we're able to reference this TV display of type text view to this separate function. I'll do the same for the other buttons, the 8 and the 7. So the function name is button 8 clicked and button 7 clicked. Let's try to relaunch the app to check if it performs exactly the same. I'll click 98789 and it works exactly as it is. When you start to work with several functions, you need to understand the scope or accessibility of the variables you are using. For example, if you don't want to keep on passing the instance of this TV display to another function, and you want it to be accessible to all the functions in this entire class, then you might consider placing the declaration outside of this onCreate function and define it as a class-level variable. In effect, it can be accessed by these 3 other functions in this class. So just underneath this class code block, if I cut this TV display declaration here and paste it on top, a gray squiggly line appears in my variable. And when I hover, it is suggesting to use a private accessibility modifier, which means only accessible within this class. Because if we don't put anything, it will be set to public by default, which means that this variable will be visible everywhere. Let's go ahead and type private. Now notice what happens when we run the app. It crashes. I'll stop the app and go back to our code. The reason is that we are already assigning our variable with a value coming from the function call findViewById, using this resource ID the moment this class is created, before this onCreate function even fires. And if you want to declare this variable as a class property like this, what you want to do is to remove this findViewById function called here. But when I do, notice an error message that appears saying property must be initialized or be abstract. For this reason, I will not be using the val declaration here, but instead, I'll use var. And then, I'm going to add a late init keyword, which stands for late initialization. And then later, in the onCreate function, I'll set the TV display using the findViewById function call. Now, since it is already accessible to this entire class, I can remove this argument. I'll also remove it here in the function definition. And let's run the app. I'll test it. And it works exactly as it is. I'll clean up my code a bit. I'll comment these lines of code by pressing Ctrl/. In the code menu, I'll choose Surround With, then Region, and Region Comments. I'll change the region description to val versus var. Then I can now collapse it, and I'll remove this code as well. Then, for this button 9, I'll do the same thing. Declare it as a private property instead of a local variable. If I'm gonna be doing this for the rest of the buttons in my XML layout, might as well place these variable initializations and the setting of onClick listeners to a separate function and call it initialize components. Now my onCreate function looks neat, just a function call to these initialize components. I'll check it one more time just to make sure that our code didn't break. And it works fine. Although we have structured our code the way we want it, and our app is running, but definitely it is far from performing its functionality as a working calculator. I'll launch my Windows Calculator app and see how it is supposed to work. As I click on each button, each number is concatenated to the previous number being displayed. So how do we accomplish this? Let me remove extra spaces here and place this function call in just one line, so that you can see the rest of the codes below. To do this, I'll declare another private property, strNumber of type string, and initialize it to an empty double quotes. Then, inside this function, button 7 clicked, I'll use this strNumber and use this compound operator of plus equal, then string 7, to concatenate whatever the previous value of this variable to string 7. Then, I'll assign it to TV display the text attribute. Let's run the app. And if I click button 7 several times, it successfully concatenates the string. The rest of the buttons are not yet functioning. So let's apply this to button 8 and button 9 as well. I'll copy and paste this code to these other two functions and change the corresponding number to 8 and 9. Let's run one more time. And it runs perfectly. Although it works, but it has several noticeable flaws. First is the way we concatenate the strings. Even though this strNumber variable is declared using the keyword var, but same with Java and other similar languages, string type is immutable. It looks like you are accessing the same string, but behind the scene, you are actually creating several string objects in your memory every time you reassign a value to your string variable. And if you want something that will properly manage your strings, you may want to consider the Kotlin's StringBuilder class. So I'll comment out this code and declare the same variable name, but this time, I'll assign it with a call to the StringBuilder class constructor. Then in here, instead of this compound operator, I can simply call the append function and pass 7 as an argument. I'll do this to the other two functions as well. Then I'll run the app to see if it still works. So far, so good. Another annoying problem here is that every time I make changes to one of these button click functions, I have to copy and paste it to the other functions as well. Notice that I only have 3 button functions implementation currently, and I don't want to repeat myself 10 times for each button from 0 to 9. With this, let me introduce you how to use arrays in Kotlin. I'll declare another private property and I'll call it number buttons and set it to type array of button using this diamond operator. And inside the initialize components function, I'll initialize this number buttons variable by calling this built-in array of function and simply enumerate values here of the specified type, such as button 7, button 8, and button 9. To make it useful, I'll use a for loop that says, for I in number buttons.indices, indices returns an integer range of valid indices for the collection. So for button 7, button 8, and button 9, the local variable I will loop through each index of 0, 1, and 2. Inside it, you can use your array like with any other arrays by accessing each element through its index, specified by variable I. This code will loop depending on how many indices these number buttons have. In effect, each button will call the same setOnClickListener. Say I placed here this button 9 click function call inside, then I'll get rid of this other call to setOnClickListeners. In effect, button 7 click and button 8 click functions are no longer in use as well. I'll run and test this app. As expected, regardless of the button number that I click, 9 will always be displayed since all buttons are calling the same function once clicked. To solve this, I change how I use this for loop. Instead of looping through its indices, I'll remove it. And what happens is that this local variable I will now represent each button instead of just index. So I no longer need to refer to this number buttons array name, and I can simply use just this I variable since it represents each button in the number buttons array. I'll run the app again to verify that it still works. Great! I'll delete these two functions that I no longer need. Then, since it is not solely intended for button 9, I'll rename this by pressing Shift F6, and I'll change it to number button click. Now, what we wanted here is not to concatenate a fixed string 9, but this number should be dynamically changing depending on the button that was clicked. In this sense, I'll accept one parameter here and give it a name, btn, and it is of type button. So now, whoever calls this number button click is required to pass an argument of type button. And what I'm going to do here is to pass in this local variable I that holds each button from the number buttons array. So depending on which button is clicked, this callback method fires, and the instance of that button that was clicked is passed here. Now I can make use of this btn parameter and simply get the text attribute of that button. Let's run the app and try it one more time. 9, 8, 7, 8, 9. And it's great. Although the rest of the buttons are not yet functioning, but with this current program structure now, it will be very easy to add functions to the rest of these buttons. All we have to do is to add the buttons that we want to the number buttons array. I'll add button 6 and button 5 for example. And that's it. No additional copy-pasting of code needed. Let's run and test our app. I'll click 5, 6, 7, 8, 9, and it works perfectly. I'll clean up my codes and remove extra spaces again. If you have noticed, our code is reduced significantly, but the functionality is improving. Now we can do the same for the operator buttons, but for this illustration, instead of using an array, I'll show you that you can also use a list. Similar to an array, I need to specify its type inside this diamond operator. In the initialize components, I'll initialize my operator buttons list using the list of function. Then I'll enumerate here button add, button sub, button mul, and button div. Similarly, I'll use a for loop and iterate for each of these operator buttons and set the onClickListener function. Inside, I want to call a function named operatorButtonClick and pass this I as an argument. And since we have not defined this function yet, I'll press Alt-Enter to show the intention action, and from the list that appears, I'll choose Create Function OperatorButtonClick, and it automatically creates a function definition for me. all I have to do is to provide the implementation. Although I can accomplish this part using the same concept that I used in the number button click function, but I'll use a different approach. The way that I'm going to show you here now is a bit longer and more traditional. You must know that there is a much shorter version of this, especially if you're going to use different libraries that can evaluate math expression in string format. But for the purpose of showing you how to use conditions and enum in Kotlin, I'll do it this way. So what I want to do is, depending on the operator button that was clicked, I'll use a variable that will hold the type of operation to perform, so that later, when I click the equals button, I know what operation to apply. Enum in Kotlin is a class. We can create an enum class in a separate file, but for you to see everything, I'll just create it in this same file. I'll collapse this class definition, and below it, I'll type enum class, then the name of our enum operator. Inside these curly braces, I'll enumerate the operators add, sub, mul, div, and none. Then I'll declare another property operator of type operator. No need to use the lateInit keyword if you will be assigning an initial content to this variable, operator.none. I also need another variable is operator click of type boolean. This will serve as my indicator to tell if any of the operator buttons is clicked. Initially, I'll set it to false. Inside this operator button click function, I'll create a condition using the if statement, asking if the button that was clicked has a text attribute of plus, and if so, I'll set the operator variable to add. I'll duplicate this code and change it to else if, compare it to minus, and then operator.sub. The shortcut key to duplicate lines of code is Ctrl-D. I'll duplicate it twice, then change this to asterisk and /, and then mul and div. In the else part, I'll set the operator to none. Finally, I'll set the is operator click variable to true. I'll run and test the app. This time, when I click an operator button, it stores what type of operation it is, then changes the is operator click to true. And when we continue to click another number, the previous display should be cleared first before concatenating the new number to the display. To accomplish this, I need a condition here in the number button click function that says, is an operator button has been clicked? Then, I need to store first whatever is in the text display before clearing its content. To do that, I need to declare first another variable I'll call operand1. I can declare this as of type double, but I'll use int instead. I'll leave this one for you to change in the programming challenge. Going back to the condition, I'll use this operand1 variable to store the current number from our StringBuilder strNumber variable. I'll convert it to string first, and then I'll convert it to int. Now I can clear my strNumber variable and change my isOperatorClicked variable back to false. We do this so that it doesn't clear the strNumber the next time we click any number button. Let's run and test our app. I'll click 9, 8, 7, 6, 5, then click plus, and now when I click 7, this if condition will be satisfied. It stores the current content of the display to operand 1 and clears it before concatenating 7. Then, the next time I click another number, it concatenates it again as usual because this condition is no longer true. Now let's do the button equals functionality. In the initialize components, I'll set the onClickListener function for this button equals. I'll call it button equal click. Then in the intention action, I'll select create button equal click. Inside this function, I need another local variable to hold my operand to. Again, I'll get whatever string number is in my StringBuilder and convert it to int. I'll declare another local variable, result, of type int, and this time, though we can accomplish this using purely if statement, But I'd like to introduce to you the when statement in Kotlin. This is somewhat similar to a switch statement in Java. So I type when, and inside this parenthesis is the variable that I'm going to evaluate. Then, inside this when code block, I can test for all the possible values of the variable being tested. Unlike with switch statement in Java, I don't have to put the keyword case. Just list all here the possible values. Say, when the value of operator is add, then use this arrow operator to point to what action to perform. What I want is to use this result variable and store the sum of operand 1 and operand 2. I'll duplicate this code 3 times and change its respective operations accordingly. We can also use an optional else statement here and set the result to 0. Then, regardless of what operation was performed, I'm going to clear my str number first, then replace it with the computed result, and finally, update the display. I'll run the app and test the result. I'll click 6, 5, then plus, then 5 equals 70. It looks good. I'll try minus 66 equals, gives me 4. Great. But when I click 9, it didn't clear the display before concatenating 9. And sure, all I need to do here is to add this is operator click and set it to true. I'll relaunch the app and test it again. 56 minus 6 equals 50. And when I click 9, it clears the display successfully and continues to concatenate other numbers after. Equals 40. Divided by 6 equals 6. Notice that there's no decimal point here because we've only used integer data type so far. I'll stop the app and I'm going to include all the buttons here starting from 0 up to 4. And I want to show you something. I'll relaunch the app and say 1, 2, 3 divided by 23 equals 5. Very good. But now notice that if I press 0, then press it again several times, it is concatenated as well continuously. Also, we still have other functionalities that we have not yet accomplished. The clear, backspace, decimal point, and sign. I'll leave this part for you as your challenge activity. So before I resolve the multiple zeros issue, I'll show you another feature of the when construct first. When working with a when statement and you don't have multiple lines of code for each condition that will be satisfied, like in this case, we only have one line, and we always use the result variable to store different possible values depending on what operator was selected. We can simplify it like this. I can remove this type declaration and move the when statement here, and then put an equal sign. And when used like this, the when statement can return a value that can be assigned to a variable. It means the individual result variable used in each possible operator value can be removed. And whatever the computed value that will be returned by this when expression will be assigned directly to the result variable. Note that when you use the when like this, the else part becomes mandatory. And since the declaration and the assignment happen simultaneously and only once, I can replace this var with val. And now, let's run the app again. I'll test it and still works perfectly. Now to resolve the multiple zeros problem, there are two areas in our program that affect how the number we click is displayed. Here in this number button click with this line of code, and the other is the button equal click with the same line of code. I'm going to refactor this one and put it in a separate function. I'll say update display, and the update display function is automatically created. I need to make sure that the number button click is also calling this function. There are several ways to resolve this one, and probably at the top of your head, you might want to put a condition here that checks if the TV display is currently showing 0, and then the rest of the code will not push through to update the display. Well, that would work, but I'll show you another way to do it. I'll declare a variable text value, and what I'm going to do here is to assign whatever this str number is holding by converting it to an integer. So it means that even if we have 2 zeros in it when we click button 0 twice, but the moment it is converted to integer type, its numeric value will be treated as just plain 0. Then, all I have to do is to use this text value and convert it back to string to be displayed. Let's check it again and run the app. If I click 0 several times, nothing happens. But if I click other number before clicking 0 several times, it works as expected. Excellent. But since we only use integer type to temporarily hold this text value, I am expecting that when we reach the limit of the integer size, say 9, 8, 7, 6, 5, 4, 3, 2, 1, and when I click 0, oops, it crashed. So how do we handle this kind of error? Kotlin has also a try-catch block that you can use to handle exceptions. I'll put a try block here, and if something went wrong when this code block, like in our case, we know that it will break when trying to convert string to int that cannot be contained. I'll catch the exception here by declaring a local variable e of type illegal argument exception. Inside this catch block, I'll change the text display to error. Also, I want to make sure that whatever is in the content of my StringBuilder str number is cleared. Let's run the app one more time. And 9, 8, 7, 6, 5, 4, 3, 2, 1, then 0, and it didn't break. We were able to handle this error successfully. I can continue clicking buttons again, and if the conversion failed, error will be displayed again. Great! There's still a lot of details that we can refine and add to this simple calculator app, but at a minimum, it serves its purpose. Plus, our main objective here is for you to learn the basic programming constructs in Kotlin that you can initially use to get you started writing codes for Android application. There's a lot more to Kotlin language that we're going to use in the coming lectures. For now, I want you to practice and familiarize yourselves with the Kotlin basics. As a challenge, try implementing the functionalities for clear, delete, or backspace, sign, and decimal point buttons. And again, thanks for watching. If you learned something of value here, please click the like and subscribe button for more programming tutorials. This is Joe Edgo and hope to see you in the next video lecture.